how to calculate the splitting pattern in the proton NMR of a compound. The splitting pattern is also called the multiplicity and the coupling pattern. So here we have ethyl ethanoate, it's an ester, it's the ethyl ester of ethanoic acid, and here is its proton NMR spectrum. So we have a triplet here, a singlet here, and a quartet here. And we can use the structure of this compound to explain why this peak is a quartet, this is a singlet, and this is a triplet. So the thing we need to think about is what's called the N+1 rule. And the N+1 rule tells you how many protons there are on the carbon atom next to the one that gives you the signal. So if we zoom into our NMR and get rid of the bits we don't need, these are the three peaks. So if I colour code the peaks according to what they are, this CH3 is this one. That CH2, the green, gives this signal. And that CH3, the red one, gives this signal. So if we look at this CH3, these protons here, this one, this one, this one, are all identical. So they'll come at the same chemical shift. The reason they're split is they're next to these two identical green protons. So this 1, 2, 3 protons are split because they're next to these green protons, and the N+1 rule will tell us how many lines these blue ones are split into. So there are 1, 2 green protons, and so the blue protons are split into 1, 2, add 1 is 3. So this here is 1, 2, 3, it's a triplet, and it's a triplet because these protons are next to two identical green protons. Now, if we look at these green protons here, they're next to 1, 2, 3 identical blue protons, and the N+1 rule says that you add 1 to the number of identical protons there are, and that gives you how many lines that the green ones are split into. So the green ones are next to 1, 2, 3 blue protons. 3 plus 1 is 4. So the green ones are 1, 2, 3, 4 lines. This is split into a quartet. Finally, if we look at the red protons, these 1, 2, 3 protons here, they're next to a carbon which doesn't have any protons attached to it. There are no protons on this carbon. So how many lines are the red protons going to be split into? This one. Those will be split into the number of hydrogens on this carbon, which is 0. We add 1 to that, so 0 plus 1 is 0. So these 1, 2, 3 protons appear as a single line, a singlet here.